Welcome to the properties of water. In this lesson, we're going to look at how the hydrogen bonding between water molecules results in water's properties. So before we start talking about some of the properties that water has, let's refresh our memories about what hydrogen bonding is. So hydrogen bonding is an intermolecular force of attraction that occurs between polar molecules that contain hydrogen. So water meets that criteria. Water has an oxygen and two hydrogens, and the oxygen region is highly negative due to the electronegativity of oxygen, whereas the hydrogen regions are slightly positive. Due to the large electronegativity difference between the oxygen atom and the hydrogen atoms, water molecules experience very strong hydrogen bonding. Now we've talked about some properties of liquids in general that depend on intermolecular forces, and we're going to look at some of those same properties again for water, now knowing that water has very strong hydrogen bonding. The strong intermolecular forces between water molecules result in a couple of properties. The first that we're going to look at is surface tension. Water molecules exhibit a very high surface tension relative to other liquids. This is because the molecules at the surface of water exhibit a strong pull towards each other based on their hydrogen bonding. This allows the surface of the water to remain unbroken even if something like an insect is walking on it. This high surface tension also results in water forming beads or droplets on various surfaces instead of just running smoothly over them. Now sometimes it's not that desirable to have the high surface tension of water, so we have ways to lower the surface tension of water, and we use things called surfactants to lower the surface tension of water. Some examples of things that contain surfactants are shampoo, detergent, and even toothpaste. And their surfactants in these products work by reducing the surface tension of water. These molecules of surfactants physically interfere with the intermolecular forces between water molecules. They block the hydrogen bonding that occurs between water molecules, and that allows them to reduce the surface tension. The second property of water that distinguishes it, that is a result of these strong intermolecular forces, is the low vapor pressure of water. Remember that vapor pressure exists because molecules are able to escape from the liquid state and enter the gas state, and those gas molecules have a certain pressure over the liquid. The strong intermolecular forces between water molecules prevents water molecules from leaving the liquid surface and becoming a gas above it. And because it's difficult for water molecules to evaporate off, we see a low vapor pressure for water. There's one more property we're going to look at for water, and that's the expansion of ice. So we know we can form ice by lowering the temperature of water. Now for most liquids, when you lower the temperature, the kinetic energy goes down, which means the molecules are moving less, they take up less space, and ultimately the molecules get closer together. That's in essence how regular thermometers work, like the one shown in the picture here. As the temperature gets colder, the liquid molecules get closer to each other, and you see the level of the liquid drop because it's taking up less volume. If the temperature goes up, the liquid expands, and the liquid goes further up the thermometer, and we see a higher temperature reading. That's how most liquids behave. And water does behave like that. Here we have 4 molecules of water in the liquid state. They're able to move past each other just like normal liquids would. And if it gets colder, they'll start slowing down and getting closer to each other, and they'll start to form intermolecular attractions, where we see attractions between the hydrogen of one water molecule and the oxygen of another. Now because it's a liquid, the molecules are always moving, and as one molecule moves away from another, the intermolecular attraction can fade. So these intermolecular attractions in a liquid are not permanent. They're constantly forming and breaking and reforming again. So now let's lower the temperature of these water molecules and let them freeze. So we're freezing, and they're going to come to a new arrangement. What happens is, with the temperature lowered, the water molecules are not moving as much, and the hydrogen bonds have a chance to really set into place. So we start seeing hydrogen bonds forming again, but these ones don't fade away the same way they did in the liquid. So we have this central water molecule right here essentially attached to 2 others because they're not able to move fast enough to escape this intermolecular attraction from the hydrogen bonding. We also have this one fading into the distance here, and this other intermolecular attraction sort of coming out towards us. And you may start to see this already, but what we have here is a tetrahedral shape, very similar to the structure of diamond that we saw before. And this locked tetrahedral arrangement of atoms forms a basis for the crystal structure of ice. And it actually turns out that the ice molecules, water when it's frozen, the water molecules, are not closer together. They actually spread out because they're locked in place by these hydrogen bonds. So solid water, ice, takes up more volume than liquid water. And if the same mass has more volume, that means the density is lower. And that's why ice is able to float in water, because even though they're the same substance, the ice formation, the ice crystal, has a lower density than liquid water. That wraps up our lesson on the properties of water due to hydrogen bonding. Write down any questions you have in your notes and bring them with you to class.